Hello and welcome to our lesson on the unit circle. The unit circle, which I'm going to help construct for you here and show you where it comes from, is going to be very useful for us in finding exact values for certain trig ratios. And what it means for a circle to be a unit circle, or the unit circle, it means that just like an angle, and we talked about angles in the previous lesson, the angles on a coordinate plane give them some reference, right? The unit circle puts a circle on a coordinate plane. So if we were to put a circle on a graph, and we were to center that circle at the origin, and we were to give that circle a radius of 1, then that is what we call the unit circle. So it's a unit circle, it's on an x and y axis, the center of the circle is at the origin, and it has 1 unit in length for its radius. Okay? So again, the purpose of the unit circle is to help us, and you're going to see this toward the end, it's to help us quickly identify exact values for certain trig ratios. So we talked about some trig ratios too, like sine and cosine and tangent. There are a few others which we'll introduce in a future lesson, but we need to be able to identify exact values for very specific trig ratios, and that's what the unit circle is going to help us with. Now, I want to show you where the unit circle comes from. It's possible that you've seen it before, but without any context on how this thing is built, it can be a bit overwhelming, okay? So we're going to start with some special right triangles. So a 30, 60, 90 triangle, for example, let me just draw your attention to this. We said across from the 30-degree angle, that's going to be our smallest side, and we'll call it x. And then the 60-degree angle would be remaining here. That's the next larger leg, would be that smaller leg times a radical 3. And then the longest side that's across from the biggest angle, the 90-degree angle, is twice that smaller leg, so 2x. Okay? Now for the unit circle, or for this to apply to our unit circle, what we're going to do is we're going to make this hypotenuse, this longest side, have a length of 1. And that means that the smaller leg would have to be half of that. So remember, if this was x, this was twice that. So I would double to go this way. I have to cut in half to go this way. Okay? So if the hypotenuse has a length of 1, that means this leg is going to have a length of 1/2. And whatever the smaller leg is, we multiply it by a radical 3 to get the longer leg. So this side over here would be 1/2 times a radical 3. And technically that's radical 3 over 1. So we could just say 1 radical 3 over 2. Okay? So if I said to identify the cosine for this 30-degree angle, well, the cosine, if you remember from our SOHCAHTOA review, right, the cosine says make a ratio of the adjacent side over the hypotenuse. So the adjacent side, sorry, that's the opposite side. The adjacent side to the 30 degrees would be radical 3 over 2, and the hypotenuse is 1. So if I made a fraction, a ratio of radical 3 over 2, and I divided it by 1, that's not going to change that radical 3 over 2. So we could say the cosine for 30 is exactly radical 3 over 2. Okay? And then the sine for 30, if you remember the sine says make a ratio of the opposite side over the hypotenuse. So from 30, this would be the opposite side, and then again 1 is the hypotenuse. Well, if I made a fraction of opposite over hypotenuse, 1/2 over 1, then I would be left with a half. So the sine for 30 would be a half. Okay? So hopefully you're with me so far here. Let me just put this back in. This was the adjacent side to that angle, and then this is the hypotenuse. Now, if I take that special right triangle and I just translate it, I'm just going to slide it over to my unit circle here. You can see I have a 30-degree angle in my unit circle. If I made a right triangle out of this, this would be the same right triangle that we were just working on a second ago. Because the radius of my circle has a length of 1, the hypotenuse of my right triangle has a length of 1. And we said that this length here would be radical 3 over 2, and this length here would be 1 over 2. Which means the coordinates at this point where that 30-degree angle hits the unit circle would be those two numbers, right? So if I wanted the coordinates at this point here, it's how far have I traveled along the x-axis, right? Well, I've gone radical 3 over 2 units. So the x value in that coordinate is radical 3 over 2. And then the y value here is how far have I gone up the y-axis. Well, that's this length here. And that we said was going to be a half. So the coordinates at that point where that 30-degree angle hits the unit circle would be radical 3 over 2, and 1/2. And radical 3 over 2 was our cosine. That was our cosine for that 30-degree angle. And then this one was our sine for our 30-degree angle. Okay? With me so far? You're going to see how this is going to be useful in a little bit, but for now, just translating that special triangle in. Now, that's in quadrant 1. If I reflected that triangle over into quadrant 2, if I just reflected this into quadrant 2, so I just made a mirror image, and let's pretend I can draw this nicely. If I made a mirror image of this triangle into quadrant 2, then what's going to happen? Well, it's the same triangle, so all the lengths would be the same, which means the coordinates here, right, would be the same as the coordinates on the other point, where I have a radical 3 over 2 here because this distance is radical 3 over 2, and then I would have a 1/2 here because this distance is still 1/2. The only difference is that in quadrant 2, our x values are negative. So we're going to make this a negative radical 3 over 2 and a positive 1/2. Now if I reflected that triangle into quadrant 3, so let me take this one and make a mirror image into quadrant 3. Same exact triangle, which means the coordinates here are exactly the same. Radical 3 over 2 is how far I've gone on the x. 1/2 is how far I've gone on the y. But in quadrant 3, both the x and the y are negative. And then if I get rid of this because it's in my way, if I reflect either one, the one from quadrant 3 or the one from quadrant 1 into quadrant 4, I'm not really making a great picture here, but hopefully you're seeing the idea, I get the same coordinates again. I've traveled radical 3 over 2 on the x, and then 1/2 on the y, but in quadrant 4, the y values are negative. Okay? So if I translate these triangles over, right, I can see the symmetry happening, right? The same thing happening in every quadrant, the same triangle happening in every quadrant. But these triangles correspond with different angles. So this triangle, let me see if I can get a good color for you to see it. This angle here was 30 degrees, right? This angle here would be how much? Well, if I have 30 degrees here, then this angle, let me need another color. This angle from here all the way to here would have to be how much? Right? Well, that would be the 180 degrees minus the 30 that's left in that triangle. So in quadrant 2, that angle, instead of being a 30-degree angle, is a 150-degree angle. Okay? Now the reason that's important to know is because if I said, what's the sine of 30 degrees, I can see right here in the coordinates that my sine of 30 degrees is 1/2. Well, if I asked you for the sine of 150 degrees, it's the same exact thing. It's 1/2, right? Or if I said, what's the cosine for 30 degrees? The cosine for 30 degrees is radical 3 over 2. Well, and then in quadrant 2, it's the same exact triangle. So if I said, what's the cosine for 150 degrees? It's got the same value, but because it's in quadrant 2, it's a negative radical 3 over 2. Okay? And then we can go a little further with this. Let me get rid of some of these highlights. Okay, so this was 150 degrees in quadrant 2. Right? Now if I went the full 150 and then another little 30 for this triangle, then this angle here would be 180 plus 30. So in quadrant 3, we're looking at 180 plus 30 is 210 degrees. The sine at 210 degrees and the cosine at 210 degrees is going to be the same as the sine and the cosine at 30 degrees as it was at 150 degrees. All three of those angles have the same sine and cosine. The only difference is, because it's in quadrant 3, the signs change, right? The positives and negatives change. Okay? And then if we looked at the angle that's all the way in quadrant 4, I'm going to go 270 degrees, and then I'm going to go a little more here. All I'm missing is that last little 30 degrees. So in quadrant 4, it's a 330 degree angle that has a cosine of radical 3 over 2 and a sine of 1 over 2. But in quadrant 4, the signs are negative. So what we have here are 4 different angles that are created by the same exact triangle. So these 4 different angles have really the same value of sine and cosine. The only thing that will change would be positive versus negative because of our quadrants. Okay, and let me just get rid of that. This was 330 degrees. And then we're going to repeat this process with a couple other versions of our special right triangle. So if I flip the triangle, if I have my 60-degree angle here and my 30-degree angle here, and we still have a radius of 1, then this side would be half of that 1, and this side would be my radical 3 over 2. So now if we're looking at the 60-degree angle, right, at our 60-degree angle, now the 1/2 is adjacent, and the radical 3 is the opposite, and 1 is still the hypotenuse. So the cosine becomes a half, and the sine becomes radical 3 over 2. So if I slid this triangle, it's translated this triangle into my unit circle, then what's going to happen is I've traveled 1/2 units along the x-axis. So at this point right here, our x value is going to be a half. And I've traveled radical 3 over 2 units up on the y-axis there, so my y coordinate has to be radical 3 over 2. And again, this is the value for the cosine of my 60-degree angle, and this is the value for my sine of my 60-degree angle. Okay? So 60 degrees in quadrant 1. Now if I reflect that triangle over to quadrant 2, what's my angle going to be? Well, it's making the same exact triangle. Well, I'm not drawing that very well, but I think you know what I'm trying to do. So let's try to copy this triangle. Same triangle, same coordinates, 1/2 and radical 3 over 2. But in quadrant 2, we have negative x values. Okay, and what's the angle that we're looking at? So we have a 60-degree angle right here. And so I want 180 total, right? This would be 180 total. If I subtract out that 60, I'll get the angle that I'm looking at here. So 180 minus the 60 means 120 degrees is the angle we're looking at. So a 120-degree angle and a 60-degree angle, they have the same cosine and sine. It's just 120 degrees is in quadrant 2, and so its cosine is a negative 1/2 instead of a positive. And you can see where we're going to go with this. I'm going to copy this into quadrant 3. And let's just pretend I'm drawing nice perfect triangles there. That means the coordinates here would be a 1/2 and a radical 3 over 2, but in quadrant 3 everything's negative. Okay, same value of sine, same value of cosine, just negative, negative because it's quadrant 3. And then how much is the angle we're looking at? So if I start at 0 and I go 180 and then another 60, then 180 and 60 means we're looking at a 240-degree angle in quadrant 3. Okay, but that angle has the same value for sine and the same value for cosine. And I guess I could leave that in there. All right, and then one more time. Try to copy this triangle into quadrant 4. Same coordinates, 1/2 and radical 3 over 2. And in quadrant 4, we have a negative y value. So same sine, same cosine, just a negative cosine because we're in quadrant 4. And the angle we're looking at this time, the angle, again, all the way to here, well, that's 60 degrees short of 360, which means the angle has to be 300 degrees. Okay, so a 60-degree angle, a 120-degree angle, a 240-degree angle, and a 300-degree angle, they all have the same reference angle. Okay, I didn't use this word on the previous one, but they all have the same reference angle, right? The reference angle for, let me use this, for the 120-degree angle would be this 60 degrees. Or the reference angle for this 240-degree angle would be 60 degrees. Or the reference angle for this 300-degree angle would be 60 degrees. So all these triangles, or all these angles have the same reference angle. They're created by the same special right triangle, which means the coordinates where they hit the unit circle, all those values are the same. Again, the only thing that changes are positives, negatives based on what quadrant we're in. Okay, I got one more round of these, and it's based on our last special right triangle, which is the 45, 45, 90. So again, let's say we have a hypotenuse of 1. Now, if you remember the 45, 45, 90 rule, it said that because these two angles are the same, these two sides would have to be the same, and to get this third side, we would take the leg and multiply by a radical 2. Well, if I have to multiply by a radical 2 to go this way, then I would have to divide by a radical 2 to go this way. And that's what we're going to do on this one. Okay? If my hypotenuse is 1, then my leg would have to be 1 divided by a radical 2. And technically, that can be rationalized. And so what we would be looking at is 1 radical 2 over radical 4, which is just 2. And this side is going to be equivalent, so it's a radical 2 over 2. Okay, so if I wanted to know the cosine for 45, here's my 45-degree angle that I'm looking at. This would be the side that's adjacent. This would be the side that's opposite. This is the hypotenuse. So if I wanted the adjacent side over the hypotenuse for my cosine, it's radical 2 over 2 over 1. So it's just radical 2 over 2. Well, in the sine of 45, the opposite over the hypotenuse, well, the opposite and the adjacent legs are the same, so it's going to be the same. Radical 2 over 2. Okay? And so if I translate this special right triangle to my unit circle, if I create that triangle here, since this is radical 2 over 2 here, the coordinates at this point have to be radical 2 over 2. And since this is radical 2 over 2, the y-coordinate here has to be radical 2 over 2. And again, that means the cosine of 45 degrees is radical 2 over 2, and the sine of 45 degrees is radical 2 over 2. Okay? Now if I take that same triangle and flip it over to quadrant 2, how is it going to look? It's going to be the same triangle, right? But what's the angle that we're looking at with this triangle? Well, the reference angle is the same, 45 degrees. But what is the value of the total angle? So 180 minus that last little 45. So if I take 180 and I subtract out that 45, I'm looking at a 135-degree angle. So a 45-degree angle and a 135-degree angle have the same sine and cosine. Both going to be radical 2 over 2. It's just 135 is in quadrant 2, so its cosine is going to be negative. Okay, oops, forgot to draw that leg here. If we take this into quadrant 3, again, in quadrant 3, what is the measure of our angle? So this time we're going 180 and then another 45. And 180 and 45 is going to be 225 degrees. So our 225-degree angle will have the same sine and cosine as 45-degree and 135-degree angle, but in quadrant 3, both are going to be negative. And then if we finally take this over to quadrant 4, I drew that really poorly. Really bad. Well, that's no better. It's because I think my circles are a little off, but just pretend that's perfect, okay? So in quadrant 4, what's the measure of the angle that we're looking at? So we have all this, right? 360 minus that last little 45, that's a 315-degree angle. So a 315-degree angle, which has the same reference angle, 45 degrees, has the same sine and, oops, I wrote that wrong, the same sine and cosine, but in quadrant 4, we have a negative y, okay? So we have these sets of angles, right? These all have the same reference angle and the same cosine and sine. These all have the same reference angle and the same value for cosine and sine. And these all have the same reference angle and the same value for cosine and sine. Just in our quadrants, right? The quadrant 1, we have positive x's, positive y's. Quadrant 2 is negative x's, positive y's. Quadrant 3, they're both negative. And then quadrant 4 is positive x, negative y. Okay? So how do we use this information? Is this. So first, let's put it all together on one clean picture here. What you're going to see is all three of our special right triangles like squished into one picture, okay? So I'm going to start with the 45s where we just left off. These would be our 45, 45, 90 triangles, right? Can you see these angles? And this was the 45-degree angle, and then this one was 135. And then this one was 180 and 45 was 225. And then over here, 360 minus 45 was 315. Okay? And let's do our 30, 60, 90s. So our 30-degree reference angles, these guys, and these guys. Okay? This was a 30-degree angle here. 180 minus the 30 means this was 150 here. And 180 plus 30 was 210 here. And then 360 minus the 30 was 330 here. And then finally, another color, we moved those 30, 60, 90s, made them 60, 30, 90s. So here and here, all four of those were the same. So this is a, come on blue, this was our 60 degrees, 60 and another 60 was 120 degrees here. And then, let's see, 270 here, minus, that one would be, oh, I'm having a brain fart. This is 240 here, sorry, moment. And then 240, and here's gonna have to be 300 degrees. And then of course we have our 0-degree angle or full circle. And then this was our 90-degree angle here. And then our 180-degree angle here. And then our 270-degree angle here. Okay, so these are all the angles that we are looking at on the unit circle. And these are the ones where we should quickly be able to identify, if we had this picture of our unit circle, quickly identify the sine or cosine for any of these angles, okay? Because the coordinates are the same for all the ones that have the 30-degree reference angle, and they're the same for all the ones that have the 45-degree reference angle, and they're the same for all the ones that have the 60-degree reference angle. So the coordinates here were radical 3 over 2 and a half. And then here was radical 2 over 2, radical 2 over 2. And actually, let me go in order. Okay, all the pink ones are radical 3 over 2, 1 over 2. So radical 3 over 2, 1 over 2. And radical 3 over 2, 1 over 2. It's going to be helpful for you to have this, I promise. Radical 3 over 2 and 1 over 2. But in quadrant 2, we've got a negative x, and quadrant 3, both negative, and then quadrant 4, y is negative. Okay? Now let's go, oh, I should have made those color coordinate. Oh, well. 45s, these are going to be radical 2 over 2. And again here, radical 2 over 2. And again here, radical 2 over 2. And then finally over here, radical 2 over 2. And in quadrant 2, negative there, both negative in quadrant 3, negative y in quadrant 4. And then finally, we have the reverse of the 30. So instead of radical 3 over 2 and then a half, it's a half, and then radical 3 over 2. Same thing here. And then same thing here. And then same thing here. Okay, but we got a negative, negative x, both negative, negative y. Okay, so there are a lot of coordinates on this, and actually I'm going to put a couple more coordinates in. What are the coordinates here where a 0-degree or 360-degree angle hits the unit circle? Well, remember the radius has a length of 1. Let's do these all the same. Length of 1. And so we are going to go over 1 and not up at all. It means the coordinates here would be 1, 0. And then at 90 degrees, we're going up not moving left or right, but going up 1. So the coordinates here would be 0, 1. And then here we're going right 1, but not up or down. And then here we're not going left or right, we're just going down 1. So we have all these coordinates, okay? So if you had this picture in front of you, and actually when I teach this in person, I would say this would be worthwhile memorizing, and I could show you some tricks for memorizing this pretty quickly. But the key is, if I ask you about the sine or the cosine for any one of these angles, all you have to do is find it and read off the x-coordinate as the cosine or the y-coordinate as the sine. So in every one of these coordinates, we have a cosine and we have a sine. Every one of these coordinates represents a value for cosine and a value for sine. So for example, here's the type of questions that you should be able to answer really quickly from this picture. If I said, what are the exact coordinates where the terminal side of each angle intersects the unit circle? So a 30-degree angle. 30-degree angle, that's this one right here. Okay, these are the coordinates. So that intersects the unit circle at radical 3 over 2 and a half. Or 120 degrees, 120 degrees right here. Those are my coordinates. Negative 1/2 and radical 3 over 2. Okay, or negative 45 degrees. So if positive 145 or if positive 45 degrees goes up, oops, let me not use my eraser. If positive 45 degrees goes up this much, then negative 45 degrees goes down that same amount. So negative 45 is the same thing as 315. So this is coterminal to a positive 315 degrees. They're the same angle, and the coordinates there are radical 2 over 2 and negative radical 2 over 2. And then negative 210, what's coterminal with negative 210? So positive 210, I'd have to go, whoops, gosh, I'd have to go halfway and then 1. So negative 210 does the same thing. The other direction, I'd go halfway and then 1. So that's going to be positive 150, and again, that's coterminal. Positive 150 would be coterminal to 210, and the coordinates at 150 or negative 210 are negative radical 3 over 2 and a half. And then 90 degrees, that's this guy right here. Coordinates are 0, 1. Okay, so that's just identifying coordinates. But the more important part is finding the exact value for our trig ratios, like I said, sine and cosine. So if I asked you for the exact value for the cosine of any one of these angles on the unit circle, all you have to do is pick out the x value in the coordinate. So if I said, what's the cosine of 45 degrees? It's no longer something we have to go to a calculator for. Cosine of 45 degrees is exactly radical 2 over 2. And if you put it into the calculator, it's going to give you a decimal, but that decimal will be radical 2 over 2. So the cosine of 45 is radical 2 over 2. Or the cosine for 180. So I go to 180, pick out the x value. Cosine for 180 is negative 1. Or what's the cosine for negative 135? So we have to figure out where that is. Positive 135, I go a quarter, and then I go 2. So negative is going to go a quarter, and then 2. That's going to be 225. So that's coterminal with, oops, put my pen back on, coterminal with 225 degrees. So negative 135, 225 are the same spot. And at 225, what's my cosine? It's negative radical 2 over 2. Negative radical 2 over 2. Okay? Negative 120. So positive, oops, I put highlighter and I didn't undo it. Oh man. Okay, let me put this back. This son of a gun. I messed up my notes. This was 225. At 225, the cosine was negative radical 2 over 2. Okay, negative 120. So negative 120, what is that coterminal to? If you need to use the picture, use it. But we're trying to make a full 360, so that's got to be 240, right? 240 to 120 makes 360, one positive, one negative. So at 240, what is my cosine? That's a negative 1/2. Cosine of negative 120 degrees is a negative 1/2. Okay, or 135. 135 is right here. Cosine is a negative radical 2 over 2. So negative radical 2 over 2. Simple as that. Just finding a location on the unit circle and identifying the x-coordinate as the value for the cosine of that angle. And then if I said find the exact value for the sine of any of the angles on the unit circle, it's again as simple as picking out a number, and this number is going to be the y value in the coordinate. So if I said what's the exact value for the sine of 60, we go to 60, we pick out the y value. So sine of 60 is going to be a radical 3 over 2. Okay? Or the sine for negative 150. Well, coterminal to 150, 360 minus 150 would be 210. So 210 degrees, and the sine is a negative 1/2. So negative 1/2. And negative 90, coterminal to that would be positive 270. And the sine there is going to be negative 1. And negative 300, coterminal to that would be 60. So negative 300 is 60. If I go to 60 degrees, the sine there is radical 3 over 2. And then negative 330, coterminal to that would be positive 30. If I go to positive 30, the sine there is a 1/2. Okay, and there it is. There's the unit circle. The unit circle, which is coming from our special right triangles. And then just kind of duplicate it all around the unit circle, right? But what it does is it gives us a quick way to identify the exact values for trig ratios, and there are more trig ratios, but for now, sine and cosine of these angles. Okay? So hopefully you've got enough to get going on your practice there. As always, though, if you need some extra help, then reach out. I will do my best to try to clarify. All right, guys, take care.